All right, science friends, welcome back. So we are going to talk a little bit about reaction basics, something called activity series, and then just some things that you might see in a reaction that might confuse you. So let's get started. First off, we're going to talk about activity series. Okay, so when we mix chemicals together, so far we've assumed that they always react, but that's not necessarily really the case. A lot of times we'll mix them together and no reaction will occur, right? I mean, it's not magic. So if I mix two things together and they form a product, if I then mix the two products together, it doesn't reform the reactant, right? So there's something there. Sometimes things will react, sometimes they won't. And it's important to know when they do and when they don't. So like I said, let's say we have this example here, right? A plus BC, let's say, reacts to form AC plus B. Okay, so my reactants right here, my reactants will react to form my products. But, or another example, sorry, another example here is K plus CaCl2 will react to form this. However, if I then take a beaker of KCl and a beaker of Ca and mix them together, they're not going to react again to reform my reactants, okay? So it's a one-way thing. So if I mix K and CaCl together, it's going to react, but it's not going to go backwards too much, really. All right, these are, for the most part, one-way reactions. Okay, so potassium is more reactive than calcium. The reason this works is because potassium is the more reactive element. So potassium is more reactive than calcium, so it will replace the calcium. Now, calcium is less reactive than potassium, so it doesn't replace the K. The Ca doesn't replace the K because the Ca is less reactive. You have to have the more reactive element by itself in order for a reaction to occur. So here's an example. I have K and I have LiCl. Li is more reactive, okay? Potassium is not the more reactive one. So potassium is not more reactive. So that means Li is more reactive, so no reaction would occur. We would not see this reaction because the more reactive element is already paired up. The more reactive element will be paired up. So K is less reactive. It will not replace the Li. The less reactive element will never replace the more reactive one. In my second example, the more reactive element will replace the Ca. K will replace Ca, but it will not replace Li. So we got to kind of figure out, maybe it'd be really nice if maybe there was a list, right, of reactivities from most to least reactive. And in fact, there is. Chemists have organized the metals into a list of reactivities. What will replace what, essentially? And they've called it an activity series. So here's an example of an activity series. It's just a very small portion, right? Because an activity series would be all metals and all non-metals. So this is just a very small snippet. So here, potassium is the most reactive. So potassium will replace anything below it. Right? Calcium is the second most reactive. So calcium will replace everything below it, but it will not replace potassium. So in a single replacement or a double replacement, well, let's not do double replacements. In single replacements, the calcium would replace magnesium, tin, lead, copper. It would replace any of these, but it would not replace the potassium. Okay, so let's do a couple examples. So what elements would replace magnesium? So I have magnesium here. What elements would replace it? All right, well, anything above magnesium would replace it. Okay, so anything above magnesium would replace it. So potassium or calcium would. Now these would have to be alone, right? Because in a single replacement, we're talking about the things that are alone. So potassium or calcium would be alone, and they would replace the magnesium if magnesium was paired with something. A reaction would occur. So if I had potassium or calcium by itself, a reaction would occur. Let's do another one. So what elements would replace lead but not magnesium? Okay, so we look at our activity series. We've got lead down here and magnesium up here. So which element is essentially above lead but below magnesium? Well, and you can see obviously that that's tin. Tin is more reactive than lead, so tin would replace lead, but it is less reactive than magnesium. It would not replace magnesium. Okay, so that's the activity series. And when I'm talking about replacing, I'm saying when those elements are by themselves. So if you go back a couple of slides, we're talking about how K was all by itself, right? Potassium was all by itself. Potassium would replace calcium if calcium was paired with something. It would bump calcium out of the way, but it wouldn't do anything with lithium because lithium, it's not shown here, but it's above our potassium. Okay, so that's activity series. We have one last thing that we really kind of need to talk about, and that's states of matter. We've talked about states of matter a lot in class. We're not going to go over it again. You know what a solid is. You know what a liquid is. But we abbreviate them because in a chemical reaction, it's a really nice thing to know if you're expecting a gas versus a solid, right? If I mix two things together and it makes a gas, it would be nice to have a heads up about that, especially if it's a toxic gas. You'd like to put in a fume hood or make sure that you're not standing over the beaker. So we put little letters in parentheses after the compound, and that tells us what the state of matter is. Now, most of them are very easy, right? S is solid, L is liquid, G is gas. Those are pretty basic ones. Those aren't too tricky. Those aren't too hard. The only one that's a little bit different is AQ. Okay, AQ stands for aqueous. Aqueous means it's something dissolved in water. A lot of times when we react things, we do it in a water solution just because it works better. It's a little bit faster. Then you're not dealing with messy, powdery things. It makes it a lot easier. So a lot of times we're dealing with aqueous. That's something dissolved in water. The water's not doing anything. The water is just the medium of the reaction. What we're really worried about is the stuff that's dissolved in it. Okay, so that should be it. Oh, I'm sorry. One last thing we do need to talk about, completely forgot about it, is how do we know a chemical reaction is occurring? Right? You did a lab in class about the chemical reactions and making observations. And one of them is, let's say, a solid appears. Okay, so if we have something if we have two aqueous solutions and all of a sudden a solid appears, you would have a little S after it. We call that a precipitate. Or let's say we have two aqueous solutions and a gas appears. All right, that would be indicator of a chemical reaction. Color change, formation of a gas, all of these things are indicators of chemical reactions. All right, so for example, here we have salt plus AgNO3. This is a precipitate right here, AgCl. It's a precipitate because it's a solid forming from two liquids. It's a solid forming from two liquids. I think that's it. Yes, it is. All right, so I hope that cleared things up. I hope you kind of understand a little bit about activity series, when a reaction will occur, when it won't occur, and I will see you all in class. Thank you.